As I said, we open the blueprint. The blueprint means to teach you everything step by step. Today, we teach you how to do the first job, which was to create the first stage of what we call nanomaterial. You have the copper wire. This copper wire, thank you very much. You need it to be what we have seen for this system is known as a copper wire gauge 14. It's about 1.6 millimeter thickness. That's what we find to be the optimum strength for the household use. Easy to manipulate, easy to work. What you do, you have to understand the work of the plasma and construct a continuous flow of plasma. We'll come into the teaching. When you have a plasma is like this. When you made those, what we call the GANs, the green materials, they're like this. But what they have magnetical from North Pole to South Pole, from North Pole to South Pole connection. At the same time, the North Pole of this partially feeds back. So if you look at this structure, you'll find out a single wire does not give you this effect. So what is the closest that you can bring these plasmas in a free condition close to each other that behave like a north and south pole? What do you see if you look? You go north and you go south, north and south, north and south. Where do we get closest to this shape? That we can continuously suppress a plasma to this shape. Spring. If you look at the spring, it gives you near enough the shape you're looking for. It goes from a north to the south, a north to the south. So, in fact, now we have found a shape that we can replicate not only the shape of the plasma, but the flow of the plasma current through too. So that was the next step. And what do you find out? If you have North Pole to North Pole, magnetical to magnetical, and gravitational to gravitational, there is a piece missing here. Because this now behaves only like the magnetical, not the gravitational part. So what we found out was easier to do. Let this be the magnetical and put another coil inside, which behaves very much like the gravitational side. So the magnetical spreads opener, the gravitational tighter. We put the gravitational in the middle. We put magnetical rejection outside. So what you get now is the increase of the two fields to come together. How you connect the north and the south, how you do this job, then dictates on you how you can manipulate the power. So what you see today, we go through the process of this, and then if you can make your units ready, your springs ready by tomorrow we go to the next step of interaction of connection. So what you need to do, you need two type of springs. One very wide and one very narrow. In a way, if I can show it to you, that you can insert one plasma inside the other. So what it means, if this is the bigger one, what we call magnetical, which is the green one, then we insert the gravitational inside. Then we see we have both whatever is released and whatever can be absorbed in the same system. As I said to you, in our trials and tests, we found copper 14 gauge 14 as the best for power production. What you need to do in a simple way, you get yourself a very thin wire, a very thin bar, that by adding the wire to it, you can still insert it into a bigger bar or bigger spring. The secret to this is when you hold the copper wire in your hand, you have to wind it anti-clockwise, which means if you go this way, it's clockwise. You have to go backwards. You wind it anti-clockwise. The number of turns is how tight you want to make it. And then when you made your turns, you have the spring shape like this. So what we find out is you need to have one of the best ways with a 14 gauge is around about 70 to 80. Oh, he loses right position. You need between 70 and 80 turns. So you need something between 70 of these notches. When you made it, you just pull it a little bit that they are not touching. There's just about a gap in it. And then you do the same. You get a bigger bar, a thicker bar, like this. And now you do the bigger bar inside. The same. That where, in fact, if you look, the thinner winding, when you separated it, can fit into the other. When you made this, you make sure that on a smaller or thinner bar, where you started the anti-clockwise turning, you leave at least the same size as what you winded free. You don't cut. You need to have a free wire on one end. On the beginning end, about 4 or 5 centimeters is good enough. On the other end, for the piece which goes in the center, you need more or less the length of the whole wire 1.5 times free, which means you don't cut the spring here. You go back, you measure the length of the spring which you made, for example, and you go 1.5 times. There is a reason for this. Then what you do, don't forget, we are only back on the wire section. Now we need to go through the process that we can now release the nanomaterials on the surface. The Keshe Foundation supporters around the world, they know. If you don't know, go on the internet, look for nano coating, Keshe Foundation YouTube. There's numbers, hundreds of videos everywhere, different people doing it different way. What you do, first of all, is that you insert the two together inside, and then you choose the way you want to create the nano coating. how you want to nano coat it. I advise you to do the insertion first before you nano coat, because you find out it's much easier. And then what you need to do, where I told you on the inner part that you have 1.5 length free without turns, you turn this back on itself through the center of itself. What it means, you go through the whole circle inside just with a wire. This is important because when you come in, you will see it on the drawings, which is on the blueprint. The wire from here, which comes out, and then this is the other end of it, which you have loose. This is the center coil. You go inside itself. So when you make this into a coil, it just falls inside. And then you leave the wire. Don't touch it. Don't do anything else with it. Then now you need to do another job. You need, this one, don't forget, was between 70 and 80 coils, both inside and outside. You need to make yourself another coil, the same, 2 inside out, 1 for about 150 to 160 turn. It's an art to learn this. So what you need is, you need a second circle. You need a second spring of between 150 to 160. Oh, I know what it is. It's the vibration of the board. Ooh, drop the book. So what you need is 2 double coils. One of 70 to 80 and one of 150 to 160. What this means is you need a small double coil like this, and you need a larger double coil like this, where once you nano coat these the same way as we showed you, you have in fact a 2 coil inside each other small and a 2 coil outside each other large. If you look at it, you sit with this. You have a coil like this and you have a coil like this. Here is 2 coils and here is 2 coils. And don't forget, the same applies to the bigger coil. Your inserted coil inside at the point of exit where you put it through your coil has to be long enough to go through itself to come out. This is important. You will understand why and how when we come to assembly. So now you have created yourself 4 coils, and I'll tell you what you need. You need 3 of this, and you need 3 of this. With one, it will not be powerful enough to meet the demand. So you're looking very strange. You understand? So what you have is, you have in fact 3 with 70 to 80 and 3 between 150 to 160 turn. If you can make this, you have got the basis for your power supply. So now you're still dealing in a matter state.